Welcome back for section 3.3. Today we're moving on to a new type of system. Instead of talking about systems of equations, we're going to talk about systems of inequalities. This will be very similar to what we did way back in the first notes of this chapter. When we were graphing systems, basically it's the same thing. You take both inequalities, graph them, then you look for the intersection, in this case an overlap. Because remember, inequalities have a region for a solution. So the solution to systems of inequalities is the overlap, the doubled up shaded region. And I will show you what that looks like. So let's jump right into what our examples are going to be like. So here, I'm starting off nice and easy for us, where they're already in slope-intercept form. So for that first one, I'm going to draw this in red. Remember, start at the y-intercept, so down at -1, slope of 2 over 1. So up 2 over 1, up 2 over 1. So I get all of these nice points here. Now I have to interpret that. The fact that it's strictly greater than is telling me that I have a dashed line. And the fact that it's greater than means I'm shading up. I'm shading above my line. So there's my shaded region for the first one. Now let's graph my second one. Start at my y-intercept, so I start up at 2. Slope of -1/3, so down 1 over 3, down 1 over 3. Then again, I can do exactly the same thing, the reverse direction. And let's interpret my inequality. Less than or equal to, so that or equal to means I'm looking at that, a solid line, and less than means I'm shading below my line. So I'm shading down here. All right, and now the double shaded region. That's what we're looking for our solution. So you can see that's where you see both blue and red. Okay, so here, just again to highlight what that looks like, that would be this region right here. Now, I don't want you to go and erase anything. This is the best way to highlight it in the video. What you should just do is darken that region, the region that I have left that you're seeing. Again, don't erase anything on your page. Just darken it in, okay? Just darken it so you can see exactly, or so I can tell that you know exactly what that region is. All right, let's look at our next one. So, again, let's start at our y-intercept. So I start up at 4, and I have a slope of -3. So down 3 over 1, down 3 over 1. I just follow that pattern. Then I can go backwards with that pattern. I interpret my inequality. So that is telling me that I have a solid line because it's less than or equal to. So a solid line, and I'm looking for values above my line. So above my line, it's going to be up here in this half. Then let's draw this. So I start down at my y-intercept. I start at that -6. Slope of 5 halves. So up 5, 1, 2, 3, 4, 5 over 2. Up 5, 1, 2, 3, 4, 5 over 2. Up 5, 1, 2, 3, 4, 5 over 2. And let's interpret my sign now. I have a dashed line. And I want to shade underneath it. And again, what we're looking for is that double shaded region. So on my screen, that region that is both blue and green. And again, just to highlight what that region looks like, that is what you're going to double shade, that region right there. Again, I don't want you erasing. I just want to highlight it for you so you know exactly what I'm talking about. That is the region, the double shaded region, where all the points in there satisfy both inequalities. All right, now, obviously there are a couple other things that can happen. So I want you to consider, first of all, don't forget that you need the y by itself, all right? So for this equation, that means I'm going to subtract 2x from both sides. So I can get the y by itself. Okay? So don't forget, always, always make sure the y is by itself so you can properly graph it. And now it's just exactly the same as what I did on the first one. Start down at 4. That's my y-intercept. And then here, don't forget, when there's nothing with the x, that means it's a slope of 1. So up 1 over 1, up 1 over 1. I get all of these points here. Interpret my inequality. I see that it's less than, or it's greater than, or equal to. So I get a solid line. And it's greater than. So I shade above my line. My second one right there. Again, starting my y-intercept, which is up at 3. And then I have a slope of -2. So down 2 over 1, down 2 over 1. Follow that pattern. Now I interpret my sign. Strictly greater than, so that means it's going to be dashed. And then I want greater than. So greater than means above my line. So I shade all of this. Then again, you need to darken in that double shaded region where both colors, where both inequalities overlap. Again, just to make it easy for you to see here, I'm going to take this away, but again, I don't want you doing any erasing on yours. I want to see all of your wonderful work. But that is the area that you should be double shading. Okay? Shade it, darken it, so I can tell you understand that is your solution. Now, obviously, saying infinitely many solutions has no meaning here because there's usually always infinitely many, okay, because we're talking about regions. So I want to show you a cool concept of how there is still a no solution area. So first, we have to get the y by itself. So I'm going to move my x over. So I get y is less than x minus 4. Now let's graph them. X plus 6. So I start at the 6, the y-intercept, and slope of 1. It's going to be a solid line. And I'm shading above it. Y is greater than that x plus 6. Let's graph this one. Y minus 4. So I start down at the -4. Then I have that slope of 1 again. It's going to be a dashed line. Then I want the y values less than that line. Now this is a case, if you notice, where there is no overlap. They're never going to touch because those are parallel lines and the shading is on the opposite side. So again, this is going to be one of our no solution regions, all right? That shaded region is never ever going to come together, never touch because they're parallel and they're shaded on opposite sides. All right. So here we're going to practice two skills, okay? We're going to practice writing inequalities. So if I give you an equation, can you write me the inequalities? And then we're going to practice on which region or which points are actually part of the solution. So let's start with the red line, okay? So for the red line, I see its y-intercept, and then it's a little bit hard to see exactly what its slope is, but it's looking to me pretty dang close to -1. Again, I know it's a little bit hard to see, but we have greater than, and then I'm just going to say that slope is -1. I know it's not exactly, but, well, let's use that point right there so we can get a little bit closer. Oops. So if I use that point as another point on the actual coordinate, that's going to be down 2 or down 3 over 4. So again, just do the best you can. I know sometimes it's difficult to find another point that's exactly on a coordinate. So again, just do the best you can when the situation comes up. Then my intercept down at 1. For my blue line, here's this intercept. Here's another point that's on the graph. So here, y, and then they're shading less than or equal to it because the shading is underneath it and it's a solid line. Up 2 over 3, and his intercept is up at 3. So you should be able to work backwards and go back to give me the equation in this case. But now for the points, okay, because the points are very interesting. We need to determine which points are part of the solution. So I think it's relatively obvious that E is in that double shaded region. Okay, so in the double shaded region, there we have it. Now, something else we have to consider. What about the points on the boundaries of the double shaded region? D is a point that's on that line, it's on the boundary, and because it's a solid line, it means the boundary is part of the solution. So D actually is. Now, don't be fooled by C, because C is on a boundary as well. But notice it's on a dashed boundary. So being on a dashed boundary, what that's communicating is the boundary actually isn't part of our solution. We should not be including it in our solution. So that's why C is not included. Then A and B are just nowhere near the double shaded region. So we're just going to ignore those altogether. But this is very important for you to understand that the boundary needs to be solid for it to be included. If it's dashed, it means it is not included in the solution. Finally, let's end with a word problem, and then we'll be on our way. You can do your summary. So a pizza parlor charges $1 for vegetable toppings and $2 for each meat topping. You want at least 5 toppings on your pizza. You have $10 to spend on toppings. How many of each can you get? All right, so how many of each? So X is going to be number of veggie toppings. Y is going to be number of meat toppings. Whenever you are looking at constructing equations, you always want to look to see what are you being asked to find. In this case, number of veggie toppings and number of meat toppings. I'm going to start here. You want to have at least 5 toppings. So our number of toppings is going to be how many total that we have. So x plus y. And we want at least 5. Now the other part of the information is $1 for each vegetable, $2 for each meat topping, and then we only have $10 to spend. So again, how much does each cost? Well, the price times how many you're getting, but we want less than or equal to $10. All right? So these 5 toppings, we want to spend at most $10. Well, we need to put these in a way that we can graph them. So for the top equation, I'm going to subtract the x. In the bottom equation, I need to subtract the x. Oh, sorry, 2x, negative x plus 10. And I need to then divide it by 2. So I get y is less than or equal to negative 1/2 x plus 5. So these are the 2 equations that I need to now graph. So let's start with the green one. I start at 5, slope of negative 1, down 1 over 1, down 1 over 1. So I am getting this. Greater than or equal to. So I put in a solid line and I shade above it. For my blue one, it also has a y-intercept at 5, but it has a slope of negative 1/2. So down 1 over 2, down 1 over 2. So I get this as my graph, and I want less than. So again, to simplify it, to make it easier for you to see, the double shaded region, the solution region, is going to be where they overlap. So it's going to be this little stretch right here. So think about how many of each you can get. It's going to be anything in there. Oh, X is representing my veggie and my meat. So this is saying I could get 4 veggie and 2 meat. I could get 6 veggie and 1 meat. I could get 2 veggie and 4 meat. So at any point you can get in there is part of your solution. It means that you're getting at least your 5 toppings and you're spending $10 or less. All right, so just as I promised, that is our last example. So, as always, if you could now take a moment to write that summary for me and then come back to class ready to do your practice work.